Okay, we're going to start with the Regents exam. This was your homework assignment over the weekend. We're going to start with question 21. You're supposed to do all circle questions greater than 20. We have two cube roots. The best way to do this question is to kind of break it up into the number parts and the variable parts. And you can do it any way you want. What I'm going to do is I'm going to put, since they're both cube roots and I'm allowed to multiply cube roots together, I'm going to put everything underneath the same cube root symbol. So 27 times 16. And I'm going to go x squared times x to the fourth. And those things that you can break up into perfect cubes, go ahead and do that. 27 is a perfect cube, so I'm going to leave it alone. 16, I'm going to break up into 8 times 2 because 8 is a perfect cube. And when I multiply these two together, I add their exponents, and I get x to the sixth, which is also a perfect cube. And then when I start to work on this, I'm going to take the 27 out as a 3. Times, I'm going to take the 8 out as a 2 because the cube root of 8 is 2. The cube root of x to the 6, remember, just divide these two, becomes x squared, and then you're left with cube roots of, and then this was brought out, this was brought out, and this was brought out, just 2. When you put this on the outside together, you're going to get 6 x squared cube roots of 2. 2. That's your final answer, which is there. And when you start taking a look at the choices, it's right here, choice 4. All right, question 22. Question 22 deals with, it says, which sketch shows the inverse? Now, remember what we're trying to do with inverse. Y is equal to a to the x. And what we mean by inverse is we're going to switch x and y. That's relatively what's happening with this. So you start with y equals a to the x equals a to the y. One of the ways we can quickly do this is to find a point that would be on this curve. If I find a point that's going to be on this curve, let x equal, let's say 0. That's a good place to start. If x is 0, then y is going to be anything to the 0 power is 1. So you're going to have the point 0, 1 on your graph. All right? So if 0, 1 is on the graph of the original function, then the point 1, 0 is going to be on the graph of your inverse, just switching x and y. So 1, 0 on the first graph here would be someplace there. So it can't be that graph. That's good, because that's the point 1, 0. This is good, because it's the point 1, 0, and this one's not. So I'm able to throw 2 out of the 3 choices away. As I continue here, if you were going to do something here and you wanted to, let's let y, as y increases, let's let y equal 2 now. If y is equal to 2, then we're going to get, as long as a is greater than 1, we're going to get a number that's going to get bigger and bigger in the x direction. So as y increases, you're going to want x to get bigger and bigger. So y is increasing and x is getting bigger and bigger. Y is increasing and x is getting bigger and bigger. And that's going to be choice 3. Over here, as y is increasing, x is going down and dipping down into the negative side, and that's not going to happen at all. That can't happen. Okay? So choice 3. Moving on to question 23. Question 23 is a simplification question. What we want to do is we want to try to factor everything we can in this problem. So when I factor x squared plus 9x equals 22, I'm going to get x and x. Slide this over. My signs are going to be different. And factors of 11 that will add up to be 9 will be plus 11 and then minus 2. That's going to be divided by x squared minus 21. That's the difference of two perfect squares. X plus 11, x minus 11. Division is going to change to multiplication, and I'm going to flip this, which is really 2 minus x over 1. I'm going to flip that as 1 over 2 minus x. And then I can start canceling. These guys are going to go away. This 2 minus x and that x minus 2 is going to go away. Remember, that's the thing that produces that negative 1. When I multiply everything at the top, all I have is a negative 1. When I write down what's left at the bottom, I have x minus 11. All right, so there's definitely going to be a fraction involved, so you can cross out these two. Now, which one is the best one? Well, if you take a look at this one, 2, you have x minus 11, but you have a positive 1. All right? This has 1 and 11 minus x. This is the one that actually has that minus 1 factored through the bottom, so that's your choice. Question 24. Question 24 is an inequality. It looks harder than what it is. Just remember, this is still kind of a proportion, and we can multiply. You have x plus 16 times 1. Right, that's this way. And then that's going to be less than or equal to then 7 times x minus 2. Okay, we're going to distribute. You get x plus 16 is less than or equal to then 7x minus 14. I'm going to get rid of the x, and I'm going to add my 14. So I'm going to get 30 on this side is less than or equal to 6x over here. Divide by your 6, and you're going to get x is greater than or equal to 5. All right, x being greater than or equal to 5 is going to be your choice 1. Question 25. Which equation represents a graph that has a period of 4 pi? Well, first we have to know the formula for period, and period is equal to 2 pi divided by the frequency, which is b, or absolute value of b. All right, so we're good with that, and they're telling us through the problem that this is 4 pi. So really we want to try to solve for b. So if you want to try to solve for b here, again, you can cross multiply. We're going to get 4 pi times b is equal to 2 pi. And then you're going to go b is equal to, divide 4 pi by both sides. So the pi's are going to cancel. 2 over 4 becomes 1/2. So b is going to become 1/2. And then which of these curves has b, which is the number in front of x? Remember, it's y equals a sine or cosine bx. The b is in front of the x. So which one of these equations has 1/2 in front of it? It's going to be choice 1. Number 26, it says the expression x squared, x plus 1 minus x plus 2 is equivalent to what? And again, the best thing to do here is to multiply everything together, add and subtract, see how things can be simplified here. They're testing you, though, on whether or not you know that this is going to be a common factor. And that's what's going on here. X plus 2 and x plus 2 are common. So I'm going to pull it out. I get x plus 2. That's my common factor times. Well, what it was multiplying was an x squared here. And what's left here is just a 1. All right. When you take a look at that as an answer, it's not up here, so we still got to play around with it. So, you know, this is definitely going to be, when I multiply these two together, we have an x and an x squared. So we're definitely going to get an x cubed as an answer. So I know it can't be either one of those choices. So it's going to either be 3 or 4. What I'm going to do is I'm going to work on this, because it looks like 4 could possibly be an answer. I'm going to break this down. I get x plus 2 times, this is the difference of two perfect squares, x plus 1 and x minus 1. And if you take a good look at what this choice 4 is, that's exactly what that is. That's what we want. Question 27. It says approximately how many degrees does 5 radians equal? So 5 radians, when I'm changing from radians to degrees, I want to multiply it by 180 over pi. All right. And when I go through this process, I'm going to go and multiply 5 times 180, and that's going to be 900 over pi. And again, they're saying approximately how many degrees, so I have to worry about the calculation. Again, approximately means it's not going to be exact. We have 900 divided by pi. And when I go ahead, and do that division, we're going to wind up with 286.47. 286.47. There it is, choice 1. It's approximately 286.47 or 286. All right, so that's 27. Moving on to question 28. 28 is your 2-point. Sorry for that interruption. 28 is your 2-point question on identities. And all it is again, as we talked about in class, make sure you change any signs or change everything to sines and cosines. So secant is 1 over cosine times, sine we'll leave alone, and cotangent, which is the reciprocal of tangent, and we know tangent sine over cosine, so cotangent is cosine over sine, and this needs to be 1. And as you can see here, they cancel, and they cancel, and right away we get 1 is equal to 1, and we're done. Number 29. 29 says, can't get the whole thing in here. '29 says, find to the nearest tenth of a square foot the area of a rhombus that has a side of 6 feet and an angle of 50. So if we're going to draw a rhombus, what do we know about a rhombus? We know a rhombus has all sides being the same, and it has an angle of 50. So if you know that that's 50 in a rhombus then, which is a parallelogram, we know all this about it because consecutive angles have to add up to be 180, opposite angles are equal, and so on. The best way to do this is to divide this into a triangle. Okay? If I divide that into a triangle, it's going to be 1/2 6 times 6 times the sine of 130. And that formula comes from your formula sheet when dealing with an area of a triangle, and you can see it right here. Okay, there's your area formula for a triangle. Alright, so that's all I did. And you might be saying, why am I doing an area of a triangle? Well, if I could find the area of one triangle or rhombus, since it is also a parallelogram, we know that those two triangles are the same. So I go ahead and go through this. I'm going to take my calculator out, and I'm going to go 0.5 times 6 times 6 times sine of 130. Let me just make sure I'm in the right mode. Oh, I'm in radian mode. I need to go to degree. And now I'm all set. Hit enter. I'm going to get about 13.788. I'm going to multiply that by 2 because those two triangles in there. So we get approximately 27.577. I guess I'll round that to the 6. Oh, can't see that. Alright, so that's where I am. And the question says find to the nearest square foot, or nearest tenth of a square foot. So we get 27 point, nearest tenth will be 6. Alright. Alright, we're going to go to question 34. Question 34, determine algebraically the x and y coordinates of all points of intersection of the graphs xy equals 10 and y equals x plus 3. The best place to start here is I'm going to start with this equation, especially if they want it algebraically. I'm not going to go, can't do to the graph, so what do we know about y? Y is equal to x plus 3, so I'm going to take that and plug it in. So I'm going to take that x plus 3 and plug it right into what y is equal to. Alright, and that's going to leave me with x times x plus 3 equals 10. That's x squared plus 3x equals 10. I'm a quadratic right now, so I got to get 0 on one side. I can try to factor this if I can. It looks like it's going to be factorable. I'm going to get plus 5 and minus 2. So I get x plus 5 is equal to 0, and I get x minus 2 is equal to 0. So x here is going to equal negative 5, and x here is going to be 2. And just make sure they both work. And we're good. So that's going to be fine. We're all set. But if you want, xy is equal to, we're trying to find both. No, they want just the x coordinate. So we're done with that. It's 31, 32. Okay, we're going to try to solve this guy. Algebraically as well, it's an absolute value question. Remember, if it's an absolute value question, you got to write it out twice. It's negative 4x plus 5. So write out the exact one that you see. And then the other one is going to be negative 4x plus 5 is going to be greater than the negative. So you have to switch it, make the other side negative. So there's the two that I need to work with. Solve this one by itself. Subtracting 5. I get negative 4x is less than, and this is going to be 8. Now, dividing by a negative 4 is what we forget. We need to flip this. It's a negative 2. Over here, we're going to subtract 5 from both sides. We're going to get a negative 4x is greater than a negative 18. Divide by negative 4, divide by negative 4. X is going to be less than, and when I go ahead and divide that out, I'm going to get 4.5. Positive 4.5. Okay, so when we want to try to see what this is going to look like as a graph, just check it out. All right, we have there's my negative 2, there's my 4.5. We're strictly less than, so we're going to be circles on each. We're greater than a negative 2 and we're less than 4.5. So this is where I'm interested in. I'm interested in this overlap. All right, when you want to write this out as a solution set correctly, it's going to be all x such that negative 2x and 4.5. And the inequality should always point to the left if you write it in ascending order. There you go. All right, so next question. Question 33. Express 4xi plus 5y I to the 8th and so on and so forth in simplest a plus bi form. Remember, you have that I chart. I to the 0 is 1. I to the first is I squared negative 1. And then I cubed negative I. We're going to go around. So 4xi is going to stay. Not too much I can do with that. Plus 5y I to the 8th. Well, I to the 8th is really I to the 0, which is 1. So this is just 5y. Plus 6x I cubed. I go to I cubed. I cubed is a negative I. That makes this whole thing minus 6x I. And then I have 2y, I to the 4th. I to the 4th again is going to be 1, so I'm just left with plus 2y. These two terms can go together. Perfect. So it's negative 2xi. These two terms can go together plus 7y. They want an a plus bi form. So it'll be 7y plus, 7y minus 2xi.